to be able to use the cloud for high-end VFX workflows, we really need a VPN because we want all of those resources to appear as if they're on a network. And there's a lot that's involved in actually setting this up properly, and it's even more involved to automate it. So, I achieved that first set point of being able to configure all of this and automate it in a pretty ad hoc type implementation a couple of years back. And most of my work since then has been about how do I try to wrap this all up in a more modular fashion, and how do I have all of the modules that describe this infrastructure be more loosely coupled. And I wouldn't say that it's completely loosely coupled yet, but it's well on its way to behaving that way. And it's much clearer how modules operate. I wouldn't say that it's easy for those modules to necessarily operate, outside of the infrastructure or in other contexts, but it's much easier to get a grasp of how all this works. So I want to do a demo today of how the VPN's working and being able to establish a connection with a deadline database that's in AWS. And we're going to connect to that over an automated VPN connection. And then we're going to submit something really simple to render on a single spot fleet instance, like just a sphere or something like that. So just to go through some of the steps about what's required for this to work is you have to have an API key for Side FX to be able to automate a Houdini download. So by going into, wrong place. By going into services, you can manage application authentication and you can create a new API key. And we will copy that into a CloudFormation template. So we have 3 CloudFormation templates that are included in the Firehawk repository, and you need to run all of them to essentially set up initial policies and your parameters that will drive everything. So we have a dev admin policy, which is something that you can apply to your username. So we'd run that and apply that to your username. And that just gives you all of the capabilities that you'd require for this to work. You have some Cloud9 policies, which are essentially instance permissions that we use for our Cloud9 IDE, where we launch everything from. And we have our parameters, which essentially drive everything. So these don't really have any parameters. This one has a username. So I'm just going to jump into this one straight away. So if we were to run that for the first time, you would see a screen somewhat like this. And I've gone through these parameters before. Not much has changed. Essentially, you don't really have to change too many of them. Some of them work by default, like this one. Some of these definitely require you to enter something, for example, your public IP address on site, because we want to be able to close down access to anything else on the internet except this public IP address. We also specify the network range for our private network. We will also specify the intended static IP address that we're going to have for our VPN. So your VPN is going to act like a router in this current configuration. We'll probably look at simplifying that so it doesn't have to be like this, but configuring the VPN like a router is a good way to go, because it means if you've got a couple of render nodes on site and you just want them to all communicate with your cloud nodes, they all appear as if they're on the same network. So this is really an important implementation step to be able to have the VPN configured as a gateway. This default works fine. This is essentially used for DHCP addresses in the VPN. You don't really have to think about it. We've got a new entry for you to copy and paste in a public key. So, on your host, and so far this has only been tested on a remote host that might be a Mac, but I don't see why it shouldn't work on Linux. It's just not tested yet. And it's certainly possible for Windows hosts to be able to use the infrastructure. It's just we can't launch the VPN from a Windows host yet. So to give you an idea, your, so we definitely don't ever want to copy that one because that's your private key. If you don't have one, you can run SSH keygen to generate one. What we really want is that one. That's the public key. So that is essentially what we would be entering into this part of the template. So we run that, we get our public key, and we just would copy and paste that in. And what this does is it means that when the infrastructure spins up, it's automatically going to generate certificates for this specific host. So this is really handy because it means that we can send certificates essentially over the wire, and those certificates themselves are actually public as well. So they're not useful unless they have the private key, which is only on this host. So long story short, we copy and paste that in, and we have a means to automate our VPN connection and establish connections with Vault in the future. Then we've got our deadline usage-based licensing. Now, I haven't actually tested this yet. It's still coming. I'll be working on that really soon. But these details are provided for you to be able to automate your usage-based licensing with Deadline, so that we automatically configure the Deadline database with this information when it spins up. So I try to automate as much of the database configuration as possible so that I'm not really too attached to manually configuring it. I want that configuration managed as code, which helps make this infrastructure immutable and reproducible. Then lastly, that's our Side FX. So that's our Side FX API key that allows us to automatically download Deadline when we're doing our image builds. Automatically download Houdini when we're doing our image builds. And this will be optional, but right now this is all I've only tested with a licensed server because I will want to add support for usage-based licensing in the future so that people don't have to have their own licensed server. And that's really exciting because it's going to be possible for us to use, say, Houdini Engine on demand and pay for it per hour, which is super enabling for users out there that might be running indie licenses. It should be possible for them to use UBL in the cloud to generate things using Engine and then render from there. So we've also added some parameters for me to share my storage from on-site. So currently my NAS exports NFS, which is for Linux. It also exports SMB, so I mount SMB on my Mac, but that also means that I could mount it to a Windows machine as well. However, in the cloud, we're only using Linux nodes, and so the Linux nodes need to be able to mount an NFS share. And so this is what's exported from my NAS. This is how I'd normally mount that export on a Linux machine. And this is the target path. So when those cloud nodes spin up, they're going to create that path and mount my NAS to that path, which is exactly the same as it is on my Mac right now. We haven't got any high performance storage running in the cloud at this point in time, even though we've done that before. This is just a first step to be able to get Deadline working, because if you can get Deadline working with your NAS mounted in the cloud, then it helps alleviate some of the challenges with moving some ephemeral data back and forth. So light data, it's easier for us to allow the VPN to take care of it than worrying about synchronizing everything with, say, S3. So heavy data, we definitely will have to create workflows to automate the synchronization of our data with S3. And I don't think it's possible to use the AWS solution called the ThinkBox AWS portal, because we need to use a VPN. And the reason why I particularly care about having a VPN is for PDG, which its automation capabilities are simply stellar, and they really will allow us to save a lot on cloud costs once we get that going. Again, I'm not running that today. That's still a work in progress. Today, my only goal is to be able to show how I can spin up a spot instance with a fully automated, immutable infrastructure configuration. So we have everything set there, and when you would press next, which I'm not going to press because everything's the same, so I'm not changing anything, this will actually set all the parameters so that you're ready to go. And then those parameters are then able to be read by our provisioning environment, or I should say our orchestration. So now I'm going to create a Cloud9 instance for us to launch everything from. Okay, so in Cloud9, we will create a new instance. We'll call it dev. And we're going to use a no ingress instance. This is quite handy. Amazon takes care of our security for us essentially. So we don't have to worry about opening up ports. We're going to take an M5 large. If you don't have at least 8 gigs of RAM, you're probably going to run into trouble. And everything else is fine, except we're going to also add a tag, which is a special tag that Firehawk looks for to find out what environment we're in. Okay, so we hit create, and while that's spinning up, I'm going to find my Git repo, and we're going to clone that in there. That's not helpful. There we go. So I'll get the latest released version. We're going to clone that. So it's 00.11. Actually, before that happens, so the next thing we have to do is assign the permissions that allow this Cloud9 instance to spin up all of our resources. So the template that we ran here, Cloud9 IAM profile policies, that created a profile that we can assign to our instance, and that essentially gives it the permission required to create all the resources. So if we go to EC2, we can find that instance that we're running, and we can right-click, go to security, and modify the IAM role. And we're going to select the role we created called Firehawk admin. Okay, Cloud9 custom admin role Firehawk. So that profile's been changed. So the next thing we actually have to do is change a setting in Cloud9 that allows the profile that we just changed there to be used. So we have to disable AWS managed temporary credentials, because otherwise we don't get the permissions that were assigned by the profile. And if we type in AWS STS get caller identity, that should show us that specific role that we created that has all the required permissions. Now we're going to clone that repository. So we can jump in. Now the first thing we're going to run is the install packages script. This also configures the instance to have 25 gigabytes of disk space on it, because it currently doesn't come with that much. I think it comes with 10. So we need a bit more space than that. So there's only a few packages that are required for this instance to have an environment that we can use. I really would like to figure out how to build our own Cloud9 instance that has all the required packages on it that could still be used with this method of authentication, because so far it only looks like custom AMIs don't get to use the SSM port forwarding solution where we don't have to worry about SSH or anything like that. So I don't really know how to, I don't think it's actually possible yet. So it's a bit frustrating because it means that Cloud9 isn't really immutable. It's the one part of the infrastructure that's not exactly immutable, but it's simple enough that it should be okay to manage. Now, so we've got everything configured. We've resized our EBS volume there, and so the first thing with a brand new instance or a brand new infrastructure deployment, you always have to go. We have to first source our environment variables always before doing anything, but then we're going to initialize everything. Okay, so when we go into init, we run terra grunt apply, terra grunt run all apply, and this will go through and initialize some things required on this host, like a private SSH key that's required just for troubleshooting, and it will also ensure a few other parameters are initialized. It's going to make sure that we have certificates generated for our HTTPS, SSL, REST API that is used by Vault. So Vault requires these certificates so that we can establish with certainty that the server we're talking to is the server that we want to be talking to. And those certificates are also used for console, which is our DNS. So our means of being able to use host names and not care about the IP addresses. We use Hashicorp's open source tool named Console to help resolve that. So we're initialized. Now, before, I've already run image builds and I've demonstrated how to do that before. But let's go to deploy, and we go to Packer Firehawk AMIs module. We're going to go into the base AMIs, and we would normally run this, and we'd build the base AMIs before we would actually build the main AMIs. Sorry. After init, I need to run that update file script again. So okay. Because we now know what the SSL certificate expiry will be, that is required for this to function. So we're going to build our base AMIs. We've already done this, so I'm going to race ahead and use something that I prepared earlier. Okay, so pretending that all of those base AMIs were built, those essentially just contain software updates, and we then build our main AMIs on top of that, which really have all of the configuration we need that we'd be changing that much more frequently as time goes on. The main purpose of the base AMIs is to essentially have a foundation that has run software updates for the operating systems like Ubuntu and CentOS. So let's go ahead and we will go and build the other AMIs. And again, I've already done this, so I'm not going to wait for it. But you know, this takes maybe 10 minutes. This might take maybe 20. And when we run this build, it's automatically going and downloading Deadline. It's going to automatically go and download Houdini. And we then have a bunch of versions of our essentially a version of our infrastructure that will be deployed that is immutable, which will help for our reproducibility down the line. For example, if a client said, hey, a year ago, how you rendered that thing for me, could we make a change to it? Immutable infrastructure makes it possible for us to operate in a way where that could be done. And I wouldn't say that this is like a fully supported workflow yet, but all of the pieces are in place for us to be able to operate that way. So let's pretend that those image builds are done. So let's head on and we will source our environment variables. Now this will pick up the images based on the repository commit. So when these images are built, they are all tagged with the commit hash that this repository is using. And we then go and find those AMI image IDs based on the commit for this repository. So now that we've got those, the next thing we need to do is we're going to go to Vault init. Before we actually spin up the Vault, when we ran that other init process, we installed a package called DNS mask, and that allows our console DNS to function, but it won't work until you reboot. So I'm just going to do that right now. It's very important that we do this because otherwise the next step will fail when you actually try to resolve host names. That just won't work. So we reboot now before we go and initialize our Vault. We source our environment variables again. And we've got 3 scripts in here just to improve the ease of use. So we've got an init script, which essentially spins up the Vault only without trying to configure it. We've also got a configure script, so once it's up, we can actually try to configure it. And then we've got destroy, which tears it all down. And once we go to the deployment stage, you won't need to worry about that. But this is a separate stage that's just in development at the moment. So it helps for it to be isolated and managed differently. So we are going to initialize the Vault, which is going to go and create a VPC. It's going to create some subnets. It's going to create 3 distributed DNS instances, which are running console. We've got 3 distributed Vault instances, so they're all highly available. And then we've got a private node that actually makes the Vault requests. That's in our private network, just along with Vault and console. And we have a single node on the public network, which is able to give us I guess it's a public endpoint that we're able to SSH into. And that also is restricted, it's restricted traffic to only accept traffic from this remote host, which we entered in that CloudFormation template. We entered that IP in. The initialization process here is, it's going to initially spin up those instances. It's going to wait for our DNS to arrive. So that it's doing that right now. Once the DNS service has arrived, then we need to be able to SSH into one of those Vault servers to initialize it. You only have to do this once for a deployment unless you destroy all your Vault data from the S3 bucket. But the first time it has to initialize it and generate a root token and get a recovery key. At some point in the future, we'll probably get rid of that completely. But at this point in time, while we're in development, we still use the root token because we occasionally need to change permissions and we don't have it all pre-configured. So we're waiting for the Vault service to arrive so that we know that the host named vault.service.console, that we can make requests of that DNS name and Vault can dish out results. So once that Vault service has arrived, then we're going to say, okay, cool, you must be ready to go, but I'm just going to SSH into one of those Vault servers. Now, we don't know their host keys yet. We don't have any means of authenticating them apart from, well, we need to use some mechanism for that host to say, hey, this is my host key and you should trust me. So we need to use a trusted channel to do that. So we can request through the AWS CLI, what is the host key for this actual instance, please? And since it's a part of our infrastructure, AWS says, yeah, I can get that for you. So the CLI comes back with the host key. And once we've got that host key, we can surely go in and continue to automate. So we've just authenticated. We've generated, we've got the recovery key and the initial root token. Now you should totally chuck that in an encrypted password manager. At this point in time, in the future, we won't be using it, but you would throw that in an encrypted password manager. But right now, that token's also, since we've authenticated to it, that vault token also exists in our home directory. That's the root token, because we're using the Vault CLI, which persists the Vault login into your home directory. So we can actually make Vault requests now, and we're logged in. You can see that it's initialized and that it's not sealed. I'm not going to go into what sealed or unsealed means in this tutorial. If you're keen to learn more, you can go to the Hashicorp website. So now that it's initialized, we should be able to configure it. And what this is going to do is it's going to use Terraform to configure all of the abilities that we require Vault to have. It sets up all of the policies, it sets up the roles, and it configures a whole bunch of things, from allowing machines that we trust to authenticate to Vault. It also allows SSH certificates to be automatically generated so that hosts know what other machines are trusted and what machines are allowed to authenticate, whilst having some protection against man-in-the-middle attacks as well. And we're also creating some storage key value areas in Vault, paths in Vault, that allow us to persist other sensitive data. So the VPN, when that turns on, that's automatically going to go and submit a certificate into Vault and a password so that we can automate a VPN on the other side. So the user doesn't have to worry about all of this stuff when all is well. But Vault allows us to automate a lot of that dynamic secrets handling and allowing the infrastructure to trust itself without us disabling any abilities that would otherwise create gaping holes in our security. Now that that's up, we should be able to go and deploy our infrastructure. So if we go to deploy, we should now be able to go, so from the deploy folder, we can run terragrunt run all apply. And now that's actually going to start to spin up the infrastructure that we intend to render on. So we're creating another VPC, and we're establishing a connection between that VPC and our Vault VPC. And we're going to create our deadline database instance in there. We're going to have a little test render node, which only has 2 cores on it. So you really couldn't render more than black frames, but it's still useful to be able to, make sure that you can at least render a black frame, because if you can't do that, then you probably can't do anything. And that node sort of serves there to help us probe things. And it also allows us to tell the difference between, like, does this little 2-thread node work, and can I scale up a massive spot fleet and have that work as well? Because if that little 2-thread node doesn't work, then your spot fleet certainly won't. So the 2-thread test node does help for being able to probe something and try to figure out what part of your configuration might be busted before you were to try and submit a big render to a spot fleet. So while this is coming up, this takes about, it's usually about 10 minutes. And this is really the part that you only have, that you would run daily from now on. So all of that stuff that we've just gone through, that's the first time configuration kind of deal. And once it's done, it's done. So we do have a dev environment that we could use daily from this point on. At the start of the day, I would spin up all my infrastructure by running what I just ran right now, terra run all apply, turn on all the infrastructure, and then when I'm done and I want to save cost, then I can just run terra run all destroy and tear all the infrastructure back down. This will also disable this. This will turn off everything. It will also turn off Vault. It will tear all of those instances away and the VPCs. But the next time that we run a terra run all apply from the deploy folder, we already have any of our configuration that is required persistent already. So we have our parameters that have been set, and we also have our Vault store. So Vault persists its data, its sensitive data, in an S3 bucket. So the next time Vault turns on, it actually pulls that encrypted database from S3, and it's then able to resume just as you were before. So Vault also automatically unseals itself using an Amazon KMS key. So unsealing is an important process with Vault. It's designed so that if it's turned off in a normal infrastructure deployment, that someone can't implicitly get into it. For example, if someone lifted the data from that S3 bucket and then they tried to turn it all on again, they wouldn't actually be able to get into it because they'd have to have the KMS key in order to unseal it. So the KMS key is like a really important part of how Vault operates for us to be able to, I guess, get access to our data if we should need to turn Vault off. It provides their, quote, break glass in case of emergency type procedure, because if you're worried about anything, you should just turn it all off. So what we just saw happen there, that is a representation of the startup user data. So all our instances have to use some user data in order to do things like authenticate into the infrastructure, pull some certificates. Maybe you want to connect to your license server or do other stuff like that. So Terraform automates that user data. It has to encode it as a base 64 string, base 64 encoded string, in order for it to go into an AWS template. So that AWS template is then able to spin up our spot fleet, and it has all of our startup scripts configured. So right now, that deadline spot config, what that's doing is it was waiting for deadline, the service, deadlinedb.service.console. That is our deadline database. It's waiting for that to register, and now that it's registered, it's going in and configuring it. So Terraform says, oh, you've arrived now. All right, I'm going to go in and update your configuration. So this is our deadline DB, I guess you'd call it configuration as code. And that means that the configuration for our DB is reproducible. And if there's any manual setting of values, we want to try and put that in code as quickly as possible. So now that that config is done, deadline database is ready to go, and we get a bunch of instructions that can guide you through the remaining steps. All of our infrastructure is up. It's actually able to function right now. You just need the ability to authenticate your remote system to it. So in order for me to do that, I'm going to generate a secret key. So Vault has the ability to generate an AWS key. So I can copy that line, paste it, and Vault is going to go and give me an AWS secret key. So as long as I've got the, again, I'm going to destroy all this, all that information is going to be gone, so you're not going to be able to do anything with it. And these are extremely constrained. So when Vault creates this access key, it really only has ability to read some of these parameters, and there's really nothing sensitive in there. Even the certificates can be public. We don't have any private key information in the certificate that we're transferring for the VPN. So we are being super careful on how we handle data here. And indeed, this information can be treated as ephemeral. We could revoke that as soon as we're done with it, which we'll be getting to at some point soon. So anyway, the purpose of this is to give us some way to automate our remote configuration so that we can make turning on the VPN really easy. So with the AWS CLI installed, what you would then do is run AWS configure, and you're going to put in your access key ID, and you're going to put in the generated secret key, and that is my region. Yours will be different. And so now we're authenticated, we would actually be able to do things like, what is the certificate authority for our known hosts? Okay, so that's an example. We were able to retrieve essentially the public certificate that allows us to know that this is what hosts in our infrastructure need to have private keys for. They need to have certificates that match against this public certificate authority that allow us to have protection against man-in-the-middle attacks. So the next step is we have the ability to retrieve some data that's going to allow us to run SSH. So for example, to actually configure our instance to work with known hosts, from the repository that I've got here cloned, we can run this command. It's going to use our AWS authentication to pull that information and configure known hosts for this machine. So if this machine tries to SSH to any other system, we shouldn't see any warnings. We shouldn't see warnings that this host is not recognized. This allows us to deal with that scenario. Lastly, for SSH to work, we also want to sign our private key so that hosts will allow us to authenticate to them. So when we run this, we're going to be pulling the certificate the Vault generated, and we're configuring it into this host so that we can now use that to SSH into a remote host. So we're now able to SSH into a private node in the infrastructure via a public node. And I know that for some of you this is super involved, but the point here and what's exciting about what's going on here is that this can all be automated now. The fact that we're just doing copy paste in a few scenarios, it's not going to be too much more for us to be able to fully automate this in the future. So if we now want to, we should be able to SSH in, and there we are. So we're actually in a private host now. We've jumped through a public host, we're into a private host, and with this command, we're also forwarding a Vault web UI. So we're able to use Vault from the UI remotely, provided we have a token. So I'm going to create an admin token. We should definitely restrict this further in the future. We're just in development at the moment, so This is fine, but the admin token's able to do a lot. And so we're going to generate that token. It's only going to last for 4 hours. And we're going to browse to this address. So if we go here, we will have our Vault UI, and we have to authenticate. So we should be able to use this token. And in the future, we'll use some other auth methods, but for now, that's what we want. And so here we are, we're able to read information in Vault. In particular, I'm interested in getting the VPN password for the admin that we currently use to create our VPN gateway. So now that we've got that, we should be able to start up the VPN. First, I'm just going to make sure that there isn't another one hanging around. So I run the destroy command in the environment that it might have been living under. And now I'm going to spin it up. And we're going to create a token for the VPN. It's allowed to make 4 requests to essentially get some information from Vault that's going to allow it to get the credentials required. And we're going to paste in the VPN user password. Okay. So it's doing the same thing that we just did before. It's using SSH to go via the Bastion host into a private host. It's making some requests with those tokens from Vault to get our private certificates, which allow us to use the VPN. So now that that's written out, we're spinning up a Vagrant VM. Now this Vagrant VM is going to spin up with the static address that we put in the CloudFormation template. It's clearly labeled. The first time you do this, you may or may not find that this host actually has that address, depending on how your router works. But it's important for you to go into your router and actually configure the static IP address assigned to this. So once it's up, I'm going to race ahead. But if I were to authenticate into my router, so for example, where DHCP operates in most routers, we're going to want to look at our leases and see here, these are all dynamic addresses, but I'd be able to click on an address for a VPN and enforce a reserved static IP address for that. And once that's done, that means it's reserved. It's always going to be there. The other thing you're going to have to do in your VPN is set up 2 static routes. And what this does, it tells anything on your network, well, when your router sees traffic trying to hit addresses in this range, it's going to send them to your VPN. So we set up a static route for everything that's in AWS, which is this range, and we say, please forward all of that to our VPN IP address. And we have to also do the same for the other VPN DHCP range that's used in the Cloud9 template. So see how we've got that address set right there. So that address, that default number there is fine to use. You need another static route configured for the VPN. And these are essentially addresses that OpenVPN uses internally for it to have channels to be able to send data between the 2 networks. But I know some of you might not be familiar with static routes. There's really only 2 numbers you've really got to care about. It's just these 2. and you've got to make sure that your router is going to send that traffic through to your VPN. Jumping back here, once this is up, we're going to be able to test that everything's working. It's up now by being able to ping the IP address for our deadline database. So we actually have an established network connection between my network and the cloud. And that means that any of my render nodes and the cloud render nodes can be shared. And that is super powerful. It's really hard to actually get that going. But if you want your hybrid infrastructure to work with cloud and to be able to save a lot of money, hybrid is really the way to go. So if we look at that deadline DB, it's the one host in the infrastructure that we currently give a static IP address to as well, because not everyone has DNS handled on both sides of this network, and you always need to be able to get at this guy on your private network. We're not going to be able to ping the DNS name for this guy without a lot more configuration, and it's something I want to try and avoid because it could push a fair bit of complexity onto people. So there we go. We're able to ping the deadline database, 28 milliseconds to AWS. When we actually ran this configuration script that automated the acquisition of the certificates, it also dropped in a certificate to be able to use deadline in our home directory. So basically you would install the deadline client. I accidentally clicked on it and it's gone and done it anyway. But you would either be installing that certificate that is in your home directory in the SSH folder, and you'd be punching in the IP address and the port number that allows you to establish a connection with a new repository. And so this is what would normally allow you to do that. You'd punch in the IP address, the port number, and you'd browse for your client certificate. Now this client certificate is different. It is sensitive. It does have a private key in there, so we treat that very carefully. But there we are, we've got deadline up. We can actually see an instance there. That's our little test instance. And that's our deadline database. So if we double click on that, we should be able to see the log for that. Now let's go and spin up Houdini. Here we've got our test scene. By default, it's going to use the certificate that you've configured when you connected the repository, which is great. So getting that deadline monitor going first is really important because it also means that this node can establish a connection and we can point at some of the instances. Now, I've only configured spot fleets for C8, engine, mantra, and C64, engine and mantra. That's how many threads. So if I want to, let's run that, and I don't know what will happen. I've actually only submitted one frame in my first test. Let's see what happens if I submit 5. So we've just submitted, and if we look here, we should see the task arrive. So we're running our deadline monitor locally, but we've established a connection with deadline in the cloud. So the deadline remote connection server and the database are running on the same host. So there's our 5 frames. And if we, if I go to super user mode, then I should be able to connect to the pulse log. And pulse is what's responsible for scaling up our spot fleet, which we've automatically configured. And it's essentially looking at the render queue and it's saying, well, if there aren't any nodes in that group to fulfill these requests, then I'm going to go and turn on some render nodes. So I've currently throttled the rate at which I think that can happen. but we should see now that there's going to be a spot fleet request that's at least starting at one node. And if we want to observe at a higher rate what's happening there, we should be able to jump into the console. We may see it here. That looks like one, since it doesn't have a good name. So there it is. We've got one host that's arriving to fulfill the request. And then the node's arrived. And there we are. We can see a render occurring. And so this spot fleet got configured by a template that is in the repository. And I haven't tested that template in multiple regions. So there's certainly a good chance in other regions that some of the instance types might not be available, might not work. So you may have to configure that spot fleet template yourself for your region. Certainly, if you try this and you have an issue, I want to know about it, because I do want to figure out how to help automate the configuration of the spot fleet template. I've got a few plans for how I'd like to do that, perhaps constructing it using Terraform, because Terraform's then going to be able to raise early on if there's something wrong with that spot fleet configuration before it's produced. So certainly generating that spot fleet template, it's a bit of a learning curve, and it's one of the things that I really wanted to automate with Firehawk, because it took ages to figure it out. And it's a big template, like it's quite a bit to manage. There we go, we've got 20% through. So I think it would be really hard for an individual that's like new to cloud to be able to figure out how to get that spot fleet template working. And to configure all of this other stuff and have a VPN. I think that all of this stuff it's really hard to do from the beginning. It took me at least a year to figure it out from the beginning and automate it. And it never made sense to me to not consider automating it, because it's so much work that anytime I wanted to make a change, it would be a person's full-time job. But by automating all of this configuration as code and this infrastructure as code, it means that as time goes by, there's less and less work required to maintain it. And I'm really, really happy that I've got this to this point now where I am able to automate a rendering configuration that I can use with Houdini ROP. I'm not at the point yet where I'm using PDG. I certainly still have to set up a few things like high performance remote storage, which I don't imagine will be too difficult, because I've already tested that before and had it working before. So we'll probably go with Amazon FSX there. So there's rendering, there's node, there's our second task. So I think by looking at the spot fleet, by looking at the pulse log, we can see we're capped to one instance, and I think I must have done something like that in the template. I must have limited it somehow. So there's probably a rate limit that I've put on what's allowed there, or I've put a license limit in place for that node type. So I need to do some investigation there. But all in all, this is definitely a success. I'm really happy that I'm finally able to get something like this going again. There's certainly more work to be done on performance and speeding things up, moving to Ubuntu. But being able to provide users with this ability to have a VPN and unify their networks with their render nodes is a huge ability, especially for Houdini effects, because PDG has the ability to save us so much in terms of cloud costs by the efficiency gains that we get from it, that I can't imagine operating cloud without it, and you really can't do it without a VPN at this point in time. So let's look at those frames. So if we go to the NAS and we go to our output, there we are. So as those nodes are finishing, they're writing the frames out. They're available right here, so I should be able to open them up in mPlay. There we are. We got a sphere. Yay. And then when this task wraps up, that spot fleet, those nodes are probably configured to sit there idle for like a couple of minutes, waiting to see if another task arrives. And I suppose that's there to compensate for any losses that you might have in constant spin up and spin down. But that spot fleet will automatically scale down. And I should probably cover like, how do you actually check that out? If you go to your instances, you'll see that node's running. Terminating it won't do you any good because it would just get replaced by the spot fleet configuration. So where is it? Why can't I see that? Oh, there it is, spot requests. So this is essentially a template that automatically scales nodes, and it's basically got a number there that it tries to reach. And by using a spot fleet, we're using preemptible nodes, so they're much, much cheaper to use, but they're at risk of being preempted. Thomas mentioned to me that I should maybe expect like an average preemption time of like 8 hours. I certainly never been preempted, but I haven't run any crazy long sims yet. So, when you're doing that sort of stuff, you want to be persisting your sim data out to a NAS, out to a high performance storage system to be able to make the best use of a spot fleet. So persisting sim data is a really good way to do that. Another way to maybe do it is that Ubuntu instances have the ability to hibernate and persist their data and get spun up again. But I really don't know how that works with Deadline. I just know that the capacity is there. I don't know how it's actually leveraged in production. So all in all, I'm really excited to share this with you. It's been like a huge amount of work. I work on this project so much, and it means a lot to me to be able to provide this ability for people, because I really just want the cloud to be as efficient as possible. I want to be able to have access to those resources for the base price. And I need direct access to the way the infrastructure works, because especially for something like an effects workflow, there's no end to the amount of control that we're going to require in the future for processes like Houdini and using PDG and synchronizing data on the fly as it's needed in an efficient way for things like collaboration. So open source infrastructure to me is probably the only way to reasonably do that and be on the bleeding edge, because I think it will be a really long time before we see really, really efficient workflows in Houdini. And it's a never-ending process. It's like tending to a garden. How efficient is your pipeline? And being able to do that with open source infrastructure is probably the only way that I think makes sense, because these types of abilities just were not available to me when I started this project 3 or 4 years ago. And open source infrastructure is really the only way I was able to figure out that this could be done, that I could use the cloud in the way that I wanted to, and run it at the most efficient cost possible. So thanks for watching. I'm looking forward to showing more updates for you guys soon.